Big data denotes just more data. The popular term big data was coined by Meta Group, now Gartner, an IT research company, to describe data sets that have high volume, high velocity, and high variety. High volume means a lot of data in relation to what we used in the past, but Meta Group did not define how much data makes it big. High velocity, which means high speed or real-time data inputs and outputs, and variety, which refers to the range of data types. Unstructured texts from emails, posts, images, video, and audio. Facebook data on 1.7 billion users would surely fit that definition. Big data is just a marketing term used to draw attention to the issues associated with technical challenges related to the management of very large data sets that are quickly updated and contain various types of unstructured data. In not so distant past, most of the data to be analyzed was structured in rows of columns, think Excel, and did not change in real time. It was updated daily, weekly, or monthly. One exception is the high-speed transaction processing used by banks and large financial institutions, but even this does not meet the variety test. Today, data also comes from emails, posts, comments, images, videos, and audio files, and keeps changing non-stop in real time. The data, whether big or small, is the foundation of all business transactions and de facto new business currency. It is the digital glue of the digital disruption, the digitization of existing processes, and the creation of new products and services. All these activities require a lot of data to work well. They also generate lots of data. The best example are social media platforms that are both data hungry and data intensive. Their success is based on the ability to collect as much relevant data as they can so they can sell it to advertisers. Their value is directly proportional to the number of users and their activities, hence data. Imagine the technical complexity of managing Facebook data generated by more than 1.7 billion users, constantly creating and sharing enormous amounts of new content globally. Another example is an e-commerce site. To build an e-commerce site, we need product data, communication data, security data, and the room to store all future transaction data. Next, we need customer data to design and implement a marketing campaign. Then we start collecting all the web traffic data, data on the behavior of visitors and prospects on our website before decided to buy, and then transaction data after the actual sale. Finally, we need fulfillment data, shipment data, and returns data, to name a few. Imagine the amount of data behind Amazon e-commerce site, which sells 480 million different products. Internet of Things applications tend to create a lot of data as well. Imagine thousands of sensors residing on oil platforms sending measurement results to a central processor every millisecond. From the analytical perspective, the amount of data may be irrelevant to the process of discovery of patterns in the data. Actually, a lot of valid research can be done on a good sample of data. We do not always need all the data to draw statistically valid conclusions. Also, more data does not necessarily mean better data, especially if it's incorrect, irrelevant, or incomplete. However, we need all the data when we want to summarize all transactions, to do detailed reports broken down by various categories such as product, region, customer, etc. Data warehouse is a term used to denote the functional scope and physical space where certain business data is stored. A data warehouse usually stores data belonging to a particular business department. Data warehouse is just a marketing term applied to large business database. Conceptually, big data may reside in a data warehouse. Companies would have a sales data warehouse, a financial data warehouse, or a marketing data warehouse, or mart or lake, denoting the scope of the logical functionality. Marts and lakes usually denote smaller databases or logical subsets of large entities. Thus, the marketing data warehouse can be made up of social media data mart or lake and the web traffic data mart or lake. If vendors continue along those lines of naming conventions, we may soon have data pools, data ponds, and data puddles. From the technical and analytical perspective, these terms are completely irrelevant. Data analysis always included queries against databases regardless how they are named, how they are related to each other, and how big they were.